All right, we are still talking about how we can apply our properties to help us add and subtract rational numbers more efficiently. But right now, we're going to focus on that whole idea of a mixed number. If it's a positive mixed number, negative mixed number, what does that mean? So don't overthink it. I know a lot of times you're like, oh, it's math. It must be really hard to do. Okay, negative 9 and 5/8. And it says rewrite each mixed number as the sum of two signed numbers. What the heck are signed numbers? Negative or positive. Okay, so don't overthink it again. All right, so negative 9 and 5/8. If I were on a number line, and it's going to be a really rough sketch, okay, I would go to negative 9. My 5/8, though, I wouldn't come back to the right. I would go 5/8 to the left. So I'd go negative 9 and I'd go a negative 5/8. And that's all this means. If I want to write it as a sum, that's going to be negative 9 plus a negative 5/8. Both of them have to be negative. Honestly, that's all this means. Negative 2.5 means it's negative 2 plus a negative 1/2. Two signed numbers. 8 and 11/12. That's 8 plus 11/12. Both are positive because this is positive. We can go the other way too. Don't freak out when you see something like this. Oh man, I've got to add a negative 1. I got to find a common denominator. No, they're both negative. So if I just pretended here, I'd go down to negative 1 and then I go down at a here's negative 1, right? So I go down negative 1 and then I go down 5/12. And I'd end up where? At a negative 1 and 5/12. They're both negative, so you can just put them together. So you're going to hear me say breaking apart mixed numbers, and you're going to say putting together mixed numbers. So 30 plus 1/8 is just 30 and 1/8. Negative 17 plus a negative 1/9, that's negative 17 and 1/9. Putting together mixed numbers. And it's all off that idea of the number line. Now, if they're different signs, we have to still follow our old rules. But the same sign, we can really just put those together. Okay, so let's kind of wrap things up and take our properties and take this idea of mixed numbers and see what we can do with it. Mr. Mitchell lost 10 pounds over the summer by jogging each week. But by winter, he had gained 5.5 pounds. Represent this situation as an expression involving signed numbers. Again, signed numbers are just a positive number or a negative number. And then we want to find his overall change. Well, if he lost 10 pounds, I'm thinking that's a negative 10. If he gained 5.1/8 pounds, then I'm thinking I need to add 5 1/8 to that. Right? That's an expression, no equal sign. Here's how this idea of breaking apart mixed numbers can help us. Okay? We can rewrite this as negative 10 plus 5 plus 1/8. Because remember, we can do that with mixed numbers, right? I can take 5 1/8 and just break it apart. And then I can just kind of follow order of operations. Negative 10 plus 5, different signs. Remember our rules. Now this is where the integer rules are going to come into play, or the rules for all adding and subtracting of rational numbers. Different signs we subtract. 10 minus 5 is 5. And then which one of these has the greater absolute value? Remember the one lesson we circled it, right? 10 is farther away from 0 than 5 is, so my solution will also be negative. Now, in this case, when I have negative 5 plus 1/8, I can't put them together. Remember what I said? These are different signs, negative and positive. So this is kind of where we got to follow those old rules. Now, some of you in your head can say, you know what? If I'm at a negative 5, think of it on the number line, and I go to the right 1/8, I know I'm at negative 4 7/8 now. Great. If you can do that, I'm cool with that. If you can't, though, remember, different signs subtract. So I'm going to go 5 minus 1/8. Way back when, you were dealing with fractions, I can borrow 1 from the 4, but remember, our 1 in this case is 8/8 because we have to have the same denominator. And what you're going to notice is that you'd get 4 7/8 again. Negative because, of course, our 5 is greater absolute value. I say bigger in quotes. Okay. All right, so unfortunately, we couldn't just put them together, but we know enough about fractions of how we can figure that out. One more example. This one I need you to pay attention to because you're going to have to do something like this in your homework. Okay? And this comes kind of like from our power standards where we have to like explain what we're doing. This is way bigger than what you're usually going to have to do, but it's going to be good practice. So Jamal is completing this a math problem, and he writes it like this: -5 5/7 plus 8 minus 3 2/7, and then he wants to replace it with a single rational number. He just wants to solve it. He just wants to get to a number at the end. We have to justify each of his steps. So we're going to look. What did he do to go from here to here? What's different? Well, he changed his subtraction. Oops. To addition. Am I abbreviating? Yes, I am. He changes subtraction to addition. Okay. Well, then what did he do from here to here? What's different? Kind of looks like he changed the order, right? What property says we can change the order of an addition problem, a string of additions? The commutative property. And honestly, if I run into it again, I'm just going to write com_prop. Okay. Now from here to here, what did he do? Well, it looks like he took my -5 5/7 and broke it apart. And he took his -3 2/7 and he broke it apart. So I'm really just going to say break apart mixed numbers. Or broke apart. I'll just write break. Break apart mixed numbers. You've heard me say that in the warm-ups before. Hopefully, anyway. All right, now let's look what he did here. He went from here to here. This looks the same. This looks the same. Ooh, looks like he again changed the order. Told you I was going to say com_prop next time. Commutative property is how we change the order. So I'm going to say that this is the com_prop. Okay with abbreviating as long as I know what it means. Okay. All right, so now we're going from here to here. Well, I got my -5, I got my -3 and my 8. Oh, look at what he did. He added -5 sevenths to -2 sevenths. And that's -7 sevenths, which is just -1. So I'm just going to say he added the fractions. You could say rational numbers, and you're going to hear me say that in the power standards, but these are just two fractions, so we added together the fractions. All right. And then, oh, look it, he added -5 and -1 together. So he added, I'm going to call them integers. Added integers. And then here he went -9, -3. Guess what he did? He added integers. Could say followed order of operations too. And he added integers. Okay. The purpose of using these properties and these like shortcuts with the breaking apart mixed numbers and things like that are not to make the problem longer. But before we learn that, before we can use that, we do need to make these problems longer because we need to recognize what we're doing, kind of ingrain it in our brains so then it just becomes natural. So don't be scared to try things, write things down. It's going to help you understand it in the long run and help you do math better in your head.